We've done it. We've made it to the last video of the school year. Section 10.7, we're going to be graphing circles, and we're going to kind of complete the circle. Getting punny. Going to complete the circle of the chapter where we started this chapter talking about angles inside of circles. And we're going to wrap it up by connecting what we've been doing with the coordinate plane and circles by graphing these circles inside of the coordinate plane. So you see what we're talking about with the picture here on the screen. And in this picture, we have a circle inside of the coordinate plane. It's been graphed in the coordinate plane. And there's actually equations to allow you to graph circles inside of the coordinate plane. And you see at the bottom of the screen, I have the equation of a circle centered at the origin. So that means if the center of your circle is at 0, 0, we can write the equation of the circle. We must know the center and we must know the radius to be able to write the equation of a circle. Because if you know the center and you know the length of the radius, you can simply spin that radius around and that'll make the rest of the circle. So our equation of a circle centered at the origin is simply x squared plus y squared equals r squared. So if we wanted to write an equation for what we see on the board here, all we would have to do is recognize the center is at 0, 0. So therefore, the equation of this graph is going to be x squared plus, oops, out of that exponent, sorry, my typing skills have taken a little bit of a drop here, x squared plus y squared equals r squared. So we need to look at our graph here. Our circle from the center to a point on the circle is 1, 2, 3, 4 units. So the radius is 4 units, and 4 squared is 16. So in order to graph this equation, to graph this circle, we would have to utilize the equation x squared plus y squared equals 16. Because a circle centered at the origin is simply x squared plus y squared equals r squared. All right, let's look at one more of these easier examples. So on the first page, the first slide of this presentation, we came up with the equation for a circle. Well, now we're going to go the other way. Given the equation, come up with the graph. And that's going to be pretty simple because this is in our circle centered at an origin form. X squared plus y squared equals 36. Well, that tells us the circle has a center at 0, 0. So we can go ahead and put the center of our circle at 0, 0 at the origin. And 36 is your r squared value. So we have to simply figure out what number squared would have given us 36. Well, that would be 6. So therefore, your radius of your circle is 6. So we go over 6 in each direction, and then we can draw the circle. I'm going to apologize in advance because I'm going to tell you this is going to go poorly with me trying to do this by hand, but the critical thing is that you have the center and your radius marked, and then you draw a circle that goes through all 4 of those points. So graphing circles centered at the origin is extremely simple. You look at your equation. The equation tells us, ooh, x squared plus y squared. Got to be a circle centered at 0. And the radius has to be 6 because 6 squared is 36. So you just put your 0 on there, your center, and then you put your 6, 6, 6, 6, draw your circle. All right, let's look at a slightly more challenging problem. All right, so now we're going to move to circles that are centered away from the origin. And what you're about to look at is going to be kind of overwhelming right away. And it's going to look like it's going to be really difficult, but it's actually something that's extremely quick and simple. So the standard form for the equation of a circle is x minus h squared plus y minus k squared equals r squared. Now you notice this formula is exactly the same as what we just did on the previous page. X squared plus y squared equals r squared. Except the h and the k have been added. Well, the h and the k simply give us the center of our circle. The point h comma k is the center of the circle. So that way this tells us the center, and the r tells us what our radius is. To graph a circle, you simply need the center and the radius. It's really complex to look at, but very, very simple to calculate. So let's go ahead and come up with a graph of a circle from an equation. So when you look at the equation at the bottom of the page, x minus 3 squared plus y plus 2 squared equals 9. In order to graph this, we want to start by identifying the center of our circle. Remember, the center comes from h comma k. So we take our h value and our k value, and that's going to be our center. Here's the one part that can trip people up on this. You notice the formula up here said x minus h. So this 3 here, the center of our circle is actually at positive 3, even though that's a minus, because the formula had a minus in it. Same thing here. This is minus k. So in order for this to be a plus 2, we actually had to have negative 2 be the center of our circle. A lot of people simply remember that inside of a parenthesis, you always do the opposite of the sign. If you have a minus 3, that's actually a positive 3 for the center. And again, the reason why that is because the formula has a minus in it. So this tells us that our center of our circle is at 3 comma negative 2. Be from our h and our k values. Then the radius of your circle, well, 9 is r squared, so therefore the radius must be 3. Like I said, once you figure out the parts of the equation, graphing circles is going to be very easy. You identify the center, and you identify the radius. You go to 3, negative 2, and put a dot. Your radius is 3, so from that center dot, you count up 3, over 3, 1, oops, I kind of missed with that one, 1, 2, 3, down 3, and again over 1, 2, 3. So we have our center. Whoops, I definitely screwed up one of those dots. This one should be down, should be there. Sorry about that. And so now we've used the center of our circle and our radius, and we can draw in the graph of the circle. So graphing circles looks like a difficult formula. X minus h squared plus y minus k squared equals r squared. But it's really quite simple. You simply take this x value in the parenthesis, this h, change the sign, that's the x value of the center of your circle. You pull the k value, change the sign, that's the y value of the center of our circle. Then we have the radius coming from r squared, and you graph your circle. All right, one more page, last screen of the year. Okay, so here we go, last slide. The last thing you're going to be asked to do is write the equation of a circle when you've been given it. So we've already been given the equation and written the circle. Now we need to be coming up with the equation from the picture of a circle. So we start by listing out our critical information. The center of the circle is going to be at the point negative 5 comma 1. So we look at where the center is. From there we count 1, 2, 3, 4 squares get us to the circle. So our radius is 4. Once you have your critical information, we can plug into our formula, which is x minus h squared plus y minus k squared equals r squared. All right, so now we can plug in our parts. H comma k. So we have x minus negative 5. Well, that's going to chop to x plus 5. Y minus k, y minus 1. R squared, 4 squared is 16. There's the equation of that circle. All right, this is it. We have a chapter test left, we have a review day, and another review day before the final. And that'll be it for geometry. No more videos.